do. No, not add. Multiply and then switch. Multiply, add, multiply, right? Okay, so let's check really quickly how we did yesterday. A, B should have been. You guys, tell me. Where was the plus? 3? 3 plus negative 3. You guys agree? Okay. Pause. Adam's doing a great job. Usually does. Where are the rest of you? I'm going to just keep on doing it until I hear the entire class. And yes, I can hear all your voices usually. That wasn't the entire class. Let's try again. When I switch, we add, right? Try again. Okay, not too bad. Keep going. Not everyone's even looking. Hey, look at us. We're working together. Is it okay if I go then? 0 and negative 10 and 10 and 0? However, the problem didn't just ask for A times B. What else did it ask for? B times A. Wait a minute. Did anybody in homework start to be like, my brain's going to spaz out if I try to look at this and go backwards? Okay. What's a way of dealing with that? Because it is hard. I wouldn't like doing that. Yeah. Why don't we just say, okay, fine for him. I'm going to have to switch this around and do B. Oops. Make it easy on your brain. Some of you are so lazy and you make things so hard on yourselves by being so lazy. No, like I'm right there with you. Like this isn't me being like I got it all together. Sometimes I'm so lazy and then I'm like, I just made things so hard on myself by not just doing what I should have done in the first place. Come on, you've been there, right? Okay. Procrastination? But this is another application. Just rewrite it and then, so easy on my brain because you guys all just told me how to do this one, so tell me how to do this one. And guys, are the math facts really that hard right now? Because it's only like keeping track of 2 numbers, right? Okay. So go ahead and tell me, what do we got? 3, which equals, what's 3 minus 3? Got it. We're so lazy again. Okay, eyes up, come on. Negative 1. And what's negative 1 minus 9? Negative 10. What is 9 plus 1? What's negative 3 plus 3? How are we doing? Yeah, we're doing all right. But what else is there? A squared. What am I going to tell you to do? Write it out. This one's A, right? Double checking. 3, negative 1, 1, 3. Wait, why has all this been legal? Why hasn't there been any no solutions? There's square matrices, and 2 by 2s and 2 by 2s aren't all the inners matching? Can we go across and down and everything matches up? Yeah. Okay, so fill in. It's totally legal. Still totally allowed to go. What do we got? And what's 9 minus 1, or 9 plus negative 1? Positive 8. What's negative 3 plus negative 3? Positive 3. What's 3 plus 3? Negative 1. Oh, we're lazy. Where'd you all go? Try again. Try again. Try again. I'm about to point to 2 numbers. Please multiply. We got it. Yeah? Oh, Jason, come on. What do we got? And what's negative 1 plus 9? Yes, I did just give up. Sometimes your parents do it too. All right. How are we doing? Okay, that was 49. What was I using 49 as an opportunity to do? Teach, maybe. Make sure that we know how to multiply matrices. Why? What was the hardest part of 8.2, I think? Multiplying matrices. Was that an easy one? Yeah. but I wanted to make sure you at least had the basics down. Now, hold on, number 69. I'm guessing it's a little bit harder. Ah, I think there's some words. Hey, look, it's applied. Whoa. Electronics manufacturer produces 3 models of LCD televisions, which are shipped by 2 warehouses. The shipment levels are represented by A. We have a matrix. Oh, look, it's so nice. They label it for us. It's even better than yesterday, yeah? I did a harder example than you guys even saw in homework. Okay. Warehouses are the columns. Models of TVs are the rows. The prices per unit are represented by. Do you think I wanted you multiplying these by hand? No. Okay. The prices per unit are represented by the matrix. Wait. This doesn't make sense. Why are there 2 columns and all of a sudden there are 3 columns? It's the price of the models. There's the price for model A. There's the price for model B. There's the price for model C. Because when we multiply, don't we go across and down? So we're going to A with A and B with B and C. Yeah, I said that right? A with A, B with B, and C with C, right? And then I'm going to go to the second house and A with A and B with B and C with C. It's going to make sense. So they tell me to do B times A. How are we going to do B times A in our nifty-difty calculator, calculadora, calculatrice? Which hopefully you guys did do, because didn't I yesterday try to make sure we all knew how to use our calculator to multiply? That just took up a lot of room. So, we're going to take this. Multiply it by this guy. My question as I'm writing this, I'm just trying to let us all visualize what's about to happen in our calculator, because I believe they say interpret the results. Why did I put a comma there and not anywhere else? I have no idea. Okay, we're supposed to interpret. So hold on, what size is this dude? What size is this dude? Oh, it's a 3 by 2, which is good because that makes it legal, right? But what's our result going to be? So wait a minute. The A and the B and the C matches with the A and the B and the C. So the 3 by 3 is going to be gone. And what's going to be remaining? What was the 1? What was measuring all this? Prices, right? And then what is this? So aren't we going to have the prices and the warehouses? Okay. So when you guys did multiply, you should have gotten a 1 by 2. When you got a 1 by 2, can someone just throw at me the totals that you got for the first row, first column?
17,699,000.
How about the second one?
17,299,000.
Why am I putting little dollar signs? Because those are prices. Why am I going to label this with warehouse 1 and warehouse 2? Because that's the total accumulated value of the merchandise in warehouse 1. And this one is the total accumulated value of the merchandise in warehouse 2. Interpret the results. That's the inventory of him, and that's the inventory of him. Not by numbers, but by price. Does that make sense? How do I analyze it? What was going on when you multiply? And I was like, oh, hey, ABC goes to ABC, and ABC goes to ABC. They all get added, so all of the inventory, the numeric inventory in warehouse 1, I just put prices to and said, insurance agent just burned down. This is how much money you should insure me for, right? Interesting. Boop. I don't know, I just made that up. We are going to our evens. Ready? Section 8.2. The first even that you need to grade is color pens at the ready, homework spirals open. The vocab for number 4 is the word identity. Matrix, I bet. Number 8, x equals -4 and y equals 9. Were you guys doing an old school like system of equations? Huh. Number 32, you were putting some matrices into an equation. Did you guys figure that out? But the cool thing is, if matrices are in this type of equation, no big deal. I can add a matrix to the other side. It's no big deal. I can divide by a scalar. It's no big deal. So they went ahead and added, 4a divided by 3 or multiplied by a third. They put their matrices in there. They did the multiplication. They did the addition. They brought in the scalar. There wasn't really a way to mess it up if you understood that all of these operations were legal. Now, number 32, you might have been like, what's the big deal? It was a super easy problem if you understood what they were asking. But here's a question. What if I was to give you something very similar to that, and I was to say, solve for x, and I was to do something like a times x plus 4b is equal to c. Capital letters are matrices. How would you solve for x? Good. No. Why? What were you allowed to divide by over here? A constant. Because constants are easy. You can bring them into matrices, you can factor them out of matrices. Didn't we talk about constants yesterday with matrices? It was called scalar multiplication. But is this scalar multiplication? This is matrix multiplication. Did we see yesterday matrix multiplication is a little bit harder? There's no such thing as dividing by a matrix. So how are we supposed to undo the matrix multiplication? What goes with undo? Didn't you guys start taking notes in section 8.3 that you should have almost ready to open up and look at? Adam said it. Did you guys hear it? Don't say it again. Undo. What word goes with undo in math? Inverse. Undo, inverse. We need an inverse. I thought inverse of matrix multiplication was division. No. Inverse of normal multiplication with constants, with real numbers, with integers, with vectors. Oh no, vectors don't do normal multiplying either. There's that whole dot product thing. Some things don't behave the same way as other things. But guess what would work? What if I multiplied A inverse on one side? And what I do to one side, I do to the, now careful with matrices, is A times B the same thing as B times A every time? Careful, I'm multiplying on the left over here. Guess what I'm going to do over here? Multiply on the left. Uh-oh, the order can matter. But what's going to happen if I multiply a matrix by its inverse? What happens when they're undone? What did we see yesterday in identity matrix? That's a thing? Oh. A matrix by its inverse or an inverse by its matrix, it should come back, if it is an inverse, it should come back to be the example we didn't get to quite finish, identity. But how does that make this all better? If this is the identity, question, what's the identity matrix times any matrix? Booyah, I just got x by itself. By dividing? No, it's illegal. That's not a thing with matrices. So what's the only way to get to x if there's matrix multiplication? The inverse. Oh, hey, do you think we should maybe learn today how to find the inverse? That's a great lead-in. Still grading. Number 44. Matrix multiplication. Dun, 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 dun. 3 by 3 and a 3 by 2 ends up being a 3 by 2. P.S. Is there another way to write this answer that would have made it look prettier? Yeah. I don't know. If I had to rewrite it, I think I'd pull a 1/3 out because 1/3 I can move to another side, equation, etc. And all of a sudden it's so much nicer. It's -8, it's +8, it's positive. How do I pull a 1/3 out of a 0? Factoring, is that multiplying or dividing when you pull something out? Dividing. What's 0 divided by a third? Who cares? What's -6? You multiply by the reciprocal? Does that make sense? Oh, it does. 1/3 of -18. You can factor out fractions even when fractions aren't there by multiplying by reciprocals. Interesting. Number 62. Whoo! Weren't you just doing RREF? Maybe you didn't realize it. Make yourself a note if you didn't realize it. All you were doing was RREF, because if you check it at the very, very end, they got their identity matrix and said, yay, we're done. That's first variable, second variable, third variable. Review from section 8.1. 2, 3 halves, 3 halves. I think with that, we're done. Where did we get stuck on in the evens? The idea. Yeah, there's a lot going on. There's a lot going on. Anything? Mm-hmm. Can I go ahead and just steal the augmented matrix? Is that cool? Remember, guys, augmented matrix, you start with a system of equations. What they said is take all the variables out. It's another way of thinking about getting to the augmented matrix. I'm going to go ahead and just copy it into notes because some of you guys might still need to take down that page of notes, right? Let me go ahead and get a blank page in here. Oops, let's go forward one. So if you have not yet written this page down in your notes, have it ready to go and get into your notes. But we are going to talk about number 62 really quickly, which is a good thing to do because even though we're moving on to section 8.3, isn't there some expectation of you guys remembering 8.1 and 8.2? Okay. First column already has a 1. Are we good? Yep. Once we have a 1 in a column, what do we go aiming for? Let's go get our zeros. How do we get zeros? Multiply this guy by the opposite coefficient. Oh, that's just 1. 1 times R1 plus R2. And multiply this guy by the opposite coefficient, negative R1 plus R3. My 1 row stays. Nice thing is we're just adding. So 1 minus 1 is going to be 0. 1 plus 2 is going to be 3. Negative 3 plus 0 is negative 3. Negative 1 plus 1 is 0. Now, these ones, hold on, I need the opposite sign. The way I wrote it, I'm going to make these guys negative and then add. So negative 1 plus 1, 0. Negative 1 minus 1, negative 2. Negative, negative 3. Positive 3 plus 1, 4. Negative, negative 1. Positive 1 plus 2, 3. How are we doing? Questions? Now that I have my first column done, I'm moving on to my second column. He's alive! But where are we aiming for? What are we aiming for? What are we getting? We need to get our 1 right there. Yeah? How do we get a 1? Add. No. Divide. So we're going to go ahead and do 1/3 of R2 into R2. 0 divided by 3 is 0. 3 divided by 3 is 1. Negative 3 divided by 3 is negative 1. 0 divided by anybody is 0. Everybody else stays. It's not their turn yet, but it's about to be. Kyle, still good? Once I have my 1s, Kyle, now what? No, not yet. Stick with the second column. Don't leave them yet. You have your 1. Now go get your zeros. Does that make sense? How do we get zeros? We multiply by the opposite and offset. There's a tour outside. Sorry, guys. Don't I need a negative 1 to cancel out? Okay, so I'm going to do negative R2 plus R1. And then I need the opposite, so positive 2, R2 plus R3. Oops, that's a B. Okay, my 0, my 1, my negative 1, my 0, all good. What am I doing? Negative 0 plus 1? Negative 1 plus 1? Negative, negative 1 minus 3 is negative 2. And, well, 0 plus anything is, there we go. 0 plus 0. What am I doing? 2 times? 2 times 1 minus 2. 2 times negative 1. Negative 2 plus 4 is 2. And then, well, 2 times 0 is 0 plus 3. First column, check. Second column, check. Everybody still good? What's it time for? So what do I go after? I had my 1. Well, actually, I had my 1 way up here, huh? I had my 1. I had my 1. It's time to get my 1. To get 1s, we divide. So I'm going to divide row 3 by half. 0 divided by anything, 0 divided by anything, 2 divided by 2, and 3 divided by, ew. Oh well, it's life. Keep them, not their turn yet, not their turn yet, not their turn yet. Ah, but now whose turn is it? Row 1 and 2, let's go bust it out. We just want to get our zeros. Multiply this guy. Now I have him by the opposite. What's the opposite of negative 1? Oh, positive 1. That's easy. So we can do row 3 plus row 2. What's the opposite of negative 2? Positive 2. Keep him. He's good, and he's good. I got tired of doing the dotted line. Sorry. Row 3 plus row 2, that's easy. 0 plus 0, 0 plus 1, negative 1 plus, 1 plus negative 1, and 3 halves plus 0. Hey, it's looking good according to what I remember from the answer key, yeah? Now times 2. 2 times 0, 0 plus 1. 2 times 0, 0 plus 0. 2 times 1, 2 minus 2. 2 times 3 halves is 3 minus 1 is done, dun, 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 dun. Whoosh. Gavin, we just finished going over homework questions, the odds and the evens, and grading. And now it's time for section 8.3. Here we go, cool kids. Inverses. We talked earlier during homework questions. Actually, in between homework questions. We talked earlier about how we need or we will need inverse matrices in order to cancel out matrix multiplication. It's the only way. So if we are going to need inverse matrices to undo matrix multiplication, well, we better learn how to find them. We better learn how to find them. So I want you guys to double check my math really quickly. Did A times B truly become the identity in the example? Did A times B truly become the identity in the example? We just reviewed matrix multiplication. Just a few of you were not quite solid on it yesterday, but I hope and I pray I gave you chances in groups. I made you point to things and say things out loud to try to make sure you had the process on your own. I know it's hard sometimes to join in when you're not exactly sure what's going on, how it's going on. But oh, what a good life lesson it is to be willing and courageous enough to speak when you're stuck and you need help. Hopefully by this point you understand matrix multiplication, but if you don't, come in during lunch, period 7, after school, grab a whiteboard. They're right up here if you don't even want to have to inconvenience me to grab out one. Just come to my desk and be like, help. Really nice. I'll say yes. Cool? There's no shame in that. Absolutely none. That's not to say that no one in your life has ever made you feel ashamed for asking for help. But that's right, that's wrong. So what am I going to say? What's negative 1 plus 2? You guys know what we're doing, right? What's positive 2 minus 2? What's negative 1 plus 1? What's 2 minus 1? Did it work with 1 and 0 and 0 and 1? Yes. Are these inverses? Yes. Why? The multiplication of them both undid either one, right? The multiplication undid. So, is B the inverse of A? Yes. Is A the inverse of B? Yes, they are inverses of each other. Addition undoes subtraction, subtraction undoes addition. Square roots undo squareds, and squareds undo square roots. ln undoes E, and E undoes log base 5 undoes 5 to the power of, and 5 to the power of undoes log base 5. Sine inverse undoes sine, and sine undoes, right? Inverses work both ways. Inverses of matrices, multiplication results in the identity. So moving on. How do we, well, sorry. Before the how-to, let's talk about the words. Before the how-to, let's talk about the words. Invertible. Wait a minute. We've seen that before with functions, haven't we? Invertible. Ooh, new term. Non-singular. Uh-oh. It's all right. It's all right. It's all right. New term. Invertible. Matrices which have, that have. Which is a struggle. You're supposed to usually have a comma before it. That's okay. Matrices that have, matrices which have inverses. The inverse exists. Same thing with functions. Some functions were invertible. They had. And some functions were not invertible. They did not have inverse relations. Invertible. Does anybody remember the other way of saying invertible for functions? We called them one-to-one. But for matrices, we don't call them one-to-one. We call them invertible, or another way of saying it is non-singular. Non-singular? Well, what's singular? Maybe you guys have heard in like English or reading. Singularly, anyway, doesn't happen very often anymore. But in math, singular, matrices without possible inverses. You think single on their own? That's okay. Singular. Poor matrix on its own. All right, Jason, I've tried. Come on, bud. Stand up. Singular. No inverse. Lone wolf. Singular matrix. No possible inverse. Don't worry, we just started writing new notes, okay? Section 8.3. So, if singular, lone wolf, no inverse, uh-oh. No inverse, but we were talking about coding. If you encode a message with a singular matrix, guess what can never be done? It can never be decoded. Well, then maybe there's not a purpose of encoding with a singular matrix unless it's just for you to be like, but maybe when we get to coding messages, we'll talk about how we cannot code or we should not code with a singular matrix. So if you were to choose a matrix to code with, you better make sure it has an inverse first, or else no one will be able to decode your message. Okay, coming back. Singular, no inverses. Non-singular, oh, well, opposite, right? So have inverses. P.S. right down here at the bottom, we've kind of talked about it, but not a lot. Non-square matrices will never have an inverse. Oh, that's something else then. If we're coding messages, we better only use square matrices. I know. I keep on alluding to that just because it's fun, but it's the end of the chapter. We have to wait. We have to prepare some of the background information to be ready. Singular, no possible inverses. Non-square matrices will never have an inverse. Why? Well, remember multiplying by an inverse has to work whichever way you're multiplying. What are the only types of inverses that won't make a difference if you flip the rows and columns? If you multiply second or multiply first? These will be okay if you're matching the 3 this way or if you're matching the 3 that way. Only square matrices will have inverses and can be multiplied both directions. Non-square matrices cannot have inverses. All non-square matrices are singular. However, ooh, you ready for one of those geometry, logic, mind-bending type statements? Singular, matrices without possible inverses. All non-square matrices are singular, but, not all singular matrices are non-square. All non-square matrices are singular. Why? You must have a square matrix in order to have it be invertible. However, not all square matrices are invertible. You have to have a square matrix in order to be able to have inverses, but not have inverses. Now, the nice thing is you guys will see some examples, or you'll see why it's impossible when we go to talk about how to find the inverse. So, all non-square never will have an inverse, always singular, but not all singular are non-square. Here's one way. Or another, but that's the next page. One way to set up and solve for an inverse. Definition of an inverse: a matrix times another matrix equals the identity. So how could we do this? Well, we could say, hey, we see that guy. We see matrix A, 1, -1, 4, -3. We could make a variable matrix. We could say like, hey, let's let X be, well, I don't know who he is. Let's call him A and B and C and D. Why? I don't know. He's a 2 by 2. Okay, cool. A and B and C and D. Let's actually make a matrix. Call him X. He has to be a 2 by 2 in order to match up with this guy. And I know it needs to equal the identity, so somehow it has to get down to here, right? Guys, as soon as we have two matrices written next to each other, technically, shouldn't we know how to multiply them? So couldn't I technically do the multiplication that is written right here? Couldn't I do? Haha. 1a plus 4c. Oh, that's horribly illegal. Let me give you a second to catch up. We have this equation that must be true in order for a matrix to be an inverse. We have an equation that must be true in order for a matrix to be an inverse. We don't know what the inverse is. That's what we're trying to find, so we can say, I don't know. Cool, let's just put in variables. Ta-da! If you are possible, I will find you. So we're going to go find them. A little bit foreboding, but that's okay. Then what did I do? Oh, it's not too bad. What did I do? Well, you guys tell me. We've been doing it all day, haven't we? What's this? A. Let's start over again. Better. Kyle's trying to be loud enough so that I don't hear the rest of you that aren't. Last time. Oh, it's so much nicer. So what am I going to do to get here? Oh. Just two variables at a time. I wonder if that's going to help me. We'll do it again. Careful. Wait a minute, two matrices are equal as long as their positions are equal, right? So what do I know about A plus 4C? What must it become? Oh. So A plus 4C equals 1. And what about negative A minus 3C? Oh, it's a system, two equations, two unknowns. What? There's another one? B plus 4D is equal to 0. Negative B minus 3D is equal to 1. It's a system, two equations, two unknowns. Elimination's super easy on this one, right? Just because of the numbers, we might have had to do elimination or substitution another way. But guys, check it. Not too bad, yeah? Don't we end up with C is equal to 1? Can't we back substitute and be like, well, if C equals 1, A plus 4 is 1, so A equals negative 3? We're halfway there. Whoa. Anyway, so B's cancel. It's an old song. 4D minus 3D is 1D. 0 plus 1 is 1. If D is 1, go back and substitute. B plus 4 is 0. Well, subtract. B equals negative 4, yeah? Now we plug back in and say, hey, I think we just finished. Why? We were trying to find X, which was the matrix that undid A, aka A inverse. And we just figured out, well, put it back in the order you found it, or put it back in the order it must go. A is negative 3, B is equal to negative 4, C is equal to 1, and D is equal to 1. Dun, 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 dun. Ha! Was that impossible? No. We just did it, didn't we? Wait, how can we make sure we're right? Multiply A times inverse or A inverse times A, and either way you should get that. The identity. Good. 0, 0, 1. What happens, though, if we were to have a 3 by 3 matrix? What would you be looking for? A 3 by 3 matrix. And you would need A, B, C, D, E, F, GHI. Oh. You would have, think about the multiplication, 3 systems of 3 unknowns. Whew. Whew. That's, 3 systems of 3 unknowns. Would it be impossible? No. Would it take a while? Yes. Are there any other ways to find inverses? And if there are, could it be expanded to find inverses of things besides 2 by 2s? Let's keep going. Oh, how could you check? We already talked about that, right? A times A inverse better equal I, and A inverse times A better equal I, but let's keep going. Ooh, to simplify the process. There's a way to simplify the process? Well, pause. Some of you are like, this doesn't look like simplifying, but wait. What did I just bring up that would be brutal? One little thing that would change that would make the whole problem so much harder. What if it wasn't a 2 by 2? Right. What we just did wasn't so bad for 2 by 2s. But man, we would much rather be able to have a system that would apply, that would work for 3 by 3s and 4 by 4s and 5 by 5s and 6 by 6s. What that system is. Booyah. Doubly augment a matrix. What? Instead of actually going through and multiplying and making systems of equations, what simplifies solving systems? RREF. But instead of RREF, just a row of constants, like a normal one system of equations, this is more complicated. We're not just solving for 2 unknowns, we're solving for 4. Or if we're looking for a 3 by 3, we're not just solving for 3 unknowns, we're solving for 9. Oof. All the systems that we would have to solve, we doubly augment and say, we're going to take the matrix whose inverse we want, augment it with the identity matrix that we want it to become, and we are going to undo the left. We're going to undo the left with RREF, getting him to be the identity. And as we do the row operations all the way across, as we bring him down to the identity, guess what we'll be doing over here? Building up our inverse. We're going to tear him down to the identity, and as we do those operations all the way across, tearing him down to the identity, we'll build him up to the inverse. It's just RREF, but further applied. It's RREF, but further applied. So there are little steps, and it is down here below, of finding an inverse matrix by taking the matrix whose inverse you want to find, doubly augmenting him with the identity matrix, doing RREF to the whole shabam, and if it is possible, if you are able, which we saw in homework, not every matrix can be put into reduced row echelon form, but if it's possible, there will be an inverse, and you will have it at the end. So as you guys are writing down the steps, I'm going to go ahead and do it. My goal is to find A inverse. I'm going to take A, doubly can I just do a solid line? Sorry, the dotted one annoys me. Okay. And I'm going to row reduce. First, getting my 1. So Kyle, thank you for letting us review row reducing today. In math, things build. You never know when your question might totally lead into exactly what we're going to need to do for the day. Ooh, I need to get a 0, right? Three minus 3 is 0. Negative 3/4 plus 1. Negative 3/4 plus 4/4 is 1/4. 3/4 plus 0, 0 plus 1. Time to go find my other 1. 4 times 0, 4 times 1/4, 4 times 3/4, 4 times 1. Oh, that. He's stuck. Go get your 0, and your inverse should appear. Opposite. 4 times 0 plus 1. 4 times 1. 4. 4 minus a fourth. Isn't 4 8/4? No. Oh. Careful. Good. 1/4 times 0 plus 1. I was looking at that guy. 1/4 times 1 is 1/4 minus 1. Oh, whew, that was close. 1/4 times 3 is 3/4. 3/4 plus 1/4 is 4/4. Yay. And then 1/4 times 4 is 4/4. 1 plus 0 is 1. Dun, 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 dun. 3, 4. Wait a minute. Was this the exact same example we did a second ago? Oh, bummer. I thought it might be. Maybe we'll find some patterns between the two. Maybe there are some shortcuts. Oh, nope. They weren't the same, but they were similar. All right, before we leave today, determinants. Before we leave today, determinants. Oh, you say you now. But if you guys are looking at that second page, isn't there another way to find an inverse? We found way 1 to be putting in the unknown or the variable matrix to be A and B and C and D. We found way 2 to be RREFing a doubly augmented matrix of whatever size, the original with an identity. But now, see that there's a special thing with matrices, kind of like a dot product for vectors that could be used in lots of ways. A determinant for matrices can be applied many different ways as well, and here's just one of them. Now, sadly, this you guys are about to see only, I apologize, it just is what it is, only works for 2x2s, which is sad, because 2x2s are the easiest. Wait, we've seen something here where there was a shortcut, but it was only for the easiest type. The cover-up method for partial fractions. It's a nice shortcut, but only worked for the easy ones. But it's a nice shortcut for the easy ones. Same thing here. Determinant, main, diagonal, minus, opposite. It only works for 2x2s. Determinant. Now you can find a determinant of any matrix. Well, yeah, you can. You can find a determinant of any matrix, and we're going to have to learn how to do that in section 8.4, whose title is Determinants of Matrices of Any Size. Well, okay, there you go. But 2x2s, it's really easy. It's A times D minus B times C. For 2x2s, it's the main diagonal minus the opposite diagonal. For 2x2s, it's basic because main minus opposite takes care of everybody. That special number, we can actually do 1 over, which can sometimes be 1 over 0, which is why some inverses don't exist. But 1 over the determinant times, oh wait, they rearranged everything. What did they do? For this formula, you can think, flip the main, right? In A times D flip spaces. Flip the main, opposite the opposite. Silly way of remembering it. Once again, shortcut only for the easy ones, but it's a nice shortcut. And with that, whoo, section 8.3, done. Homework tomorrow. Bye, guys. See ya. Great job. Some of you, if you don't get row reducing, come in, grab a whiteboard, say help. Come in, get a whiteboard, and say help. I would love to. Please give me the chance. Yeah.